All right. Thanks, Tom, for your patience. Go ahead and kick it off now.
Okay, great. Well, thanks, Ben, and I appreciate everyone joining today. Seems like there's quite a crowd online. And thanks for letting me represent Lenovo's networking product. Hopefully you'll find the presentation a little bit different and interesting. I'm trying to minimize the number of slides that show a switch with port counts and port speeds and things like that, because all of those things are available online. But before I start the presentation, I've been involved in networking ever since there were terminals connected to mainframes. And to give you an example, I've done some token ring networking, Ethernet networking at 3Com. I've done networking with startups. I've worked for IBM since 2013, and then moved to Lenovo last year. And if you're familiar with the IBM networking product, some of the products we'll talk about today are the same, and we also have some new products at Lenovo. So let's get started. So this is my plan for the outline, just a brief introduction of Lenovo networking and where we started. And then we're going to go kind of off Lenovo and into just really the state of networking today, talk about some of the other vendors that provide networking. And then we'll go into, I've got software-defined data center, but it's also networking, software-defined networking and software-defined, the data center as a whole. And then look at the products and functionality that we can provide in our product. And then, unfortunately, I do have to cover some slides that show port count and what the switches look like. And then we'll kind of wrap it up with some customer designs that were actually in production. And then finally, a resource page for you. I'm in one of the networking field guides. There are 10 of us around the country that support customers and partners and Lenovo service sellers across the country. And of course, we have people around the world, but I believe this call is just limited to North America. So that's where the emphasis is on. So first of all, what's Lenovo networking? We provide top-of-rack switches and switches that are embedded in our Flex chassis, as well as Blade Center chassis. And network operating system is basically the operating system that runs on all of our switches. And we have a consistent network operating system across the switches. So the lowest end 1 gig switch and the highest end 40 gig switch all have the same consistent interface to them. And then we have a management tool that's an SNMP-based tool for managing all of the switches, whether they're inside a chassis or if they're just a standalone top-of-rack switch. And you'll see that in many cases, today we're going to focus on the top-of-rack switches, but for each top-of-rack switch we talk about, there's a partner switch that is in either a Flex chassis or a Blade Center chassis as well, and they provide the same functionality. So if we talk about something today and you happen to have a Flex chassis or you're looking at it, you'll also be able to run that same functionality on the switches that are inside the chassis. So really what networking connects to everything, right? If there's no network, there's no any peer-to-peer communication and user-to-server communication or storage connectivity. So while networking is usually thought of as plumbing, right? Plumbing is great as long as it's working. Nobody talks about plumbing. But as soon as it breaks or if there's any kind of a jam, then it becomes a big issue. So I like to think it's an important topic. So where did we start? Myself personally, I started with IBM with the Lenovo switches, but there's a long history of networking companies. Alcan was the original company, and then Nortel. And then what Nortel did was they made Blade switches for IBM and HP, and they decided to spin the company into a separate company, probably because HP wasn't real happy with buying switches from Nortel. So they came up with a company called Blade Technologies, and Blade Networks designed these Blade switches for IBM and HP chassis. And then they decided, well, since we're doing these great Blade chassis, we'll create standalone separate top-of-rack switches. And so they offered both products at that point. And then in 2010, IBM bought the company. And still up to the day that we moved from IBM to Lenovo, we were still making switches for HP chassis, but most of those had been replaced by newer HP switches. But we continue with a strong portfolio inside the Lenovo Flex chassis. Something I was surprised with even when I started with IBM is these switches are in over 350 of the top Fortune 500 companies in the United States. So they're in big companies where blade centers are, where flex chassis, and even standalone top of rack. For example, if you have an IBM Big Insight implementation that was a number of, maybe a rack of x86 servers, most of those implementations included at least a pair of 10 gig IBM at that time rack switches to support that because of the performance and the connectivity that we could provide. So you see a number of different markets that we're in, but basically, you know, many large customers have these Lenovo switches in their network. And kind of the last start-off slide is we really focus on 3 key values. Simplicity. We don't want to add another difficult piece of infrastructure to manage and configure. So we focus on providing simple solutions that are easy to implement. And in many cases, once they're implemented, you don't have to touch them again through the life of the product. And that seems true for just even a pair of top-of-rack switches or into one of our implementations of our Flex system that we can configure up to 9 different Flex chassis all in the same pod, we call it, which would go across multiple racks and provide that same simplicity as just a pair of rack switches. As far as cloud ready, so what cloud in the Lenovo terms is really the software defined environment, so that you know, the end all goal to cloud and what cloud providers use themselves is the ability to not have to touch every piece of infrastructure when they bring up a new application. There isn't someone that has to configure the networking switches and the storage and the VMs and things like that. It's all automated, whether it's scripted tools or you know, web-based tools and applications that do that. And we're going to talk about some of that in the presentation about what really cloud ready means to Lenovo. And one of the parts of software-defined networking requires a feature called VXLAN gateways. And that's actually a hardware-based feature. So if you're looking at switches, that's something that you really want to look for. And it's one of a newer feature that requires, you know, that feature has to be built into the hardware when you're looking at switches, you know, for this future cloud-type implementation. And then, of course, we're open. We support standard protocols, of course, layer 2 protocols like spanning tree, and layer 3 protocols like OSPF and BGP, and protocols that allow you to discover switches in a network and talk to switches, of course, that are non-Lenovo based. You know, basically, in the Ethernet market, most switches, you plug them together and they'll start talking with just minimal configuration. So you don't really have the interoperability issues that you have, say, in a fiber channel environment or some other networking technology. And the last 2 things are really software-defined networking implementation, and Neutron, as we'll find out, is part of the OpenStack that deals with the networking coordination. So the next 2 slides we'll talk about just what the traditional network environment is like, and if you have a network or if you're selling to customers with networks, you'll probably be very familiar with the next 10 slides. And it's really just to kind of set the table for when we talk about the software-defined environment. Hopefully I didn't leave anybody out. I know I left one out. Brocade makes Ethernet switches as well, but for these are the bigger players in the Ethernet network. And granted, Cisco is the largest player, and the players on the left-hand side are strictly networking vendors, while the players in the center and the right side are both networking and compute, and as well as storage as well. If you look at these switches, other than the one that says Dell, it's hard to tell which manufacturer produced which switch. I can give you a hint, the purple one on the upper right, that's Extreme because they use purple colors, but most of the other vendors use some shade of gray or some shade of black And from the base of the switch, you have to get pretty close to determine if it's a Cisco switch or a Juniper switch. And there's a reason why that is, and one of them is the physical space, right? Each of those ports picks up an RJ45 cable or an SFP transceiver, takes up a fixed amount of space, and most people switches have power in the back, so there's no power cables in the front, but so you're physically limited. And all of these switches we're looking at are 1U high. They're all 19-inch rack mountable, things like that are all similar. And if you think of what happened in the server world with virtualization years ago, kind of changed it is Intel, right? So Intel made it so that you have an Intel server and you run VMware on it. You can run about any host operating system, Windows or Linux, on top of those things. And it's because the server vendors and server customers both started to really just focus on Intel, and that's what really changed the market. You have an Intel server, you can run VMware on it, or you can run Hyper-V on it, or you can run Linux straight on it. But the whole idea is that if you start with the Intel base, that kind of set the level playing field. Well, and in the market for networking, it's really the same idea. There are some exceptions, and it's a little different, but in the networking world, we have Broadcom. And Broadcom is the Intel of networking. Most of the switches that you see on the slide, excuse me, have a Broadcom switching ASIC in it. And the most current ASIC is called a Broadcom Trident 2. So for the most part, if you're getting a 48-port, 10-gig switch with either 4 or some of the newer switches have 6 40-gig ports on them. And in a lot of cases, it's a Broadcom Trident 2 switch. And so you're basically buying the Intel of networking by using a Broadcom. So here I've got some model numbers to match with the switches. But they're all basically the same. They're all wire speed switches. They provide similar functionality. The price range on a 48-port switch, I did some just generic Google searches the other day on prices, and for a switch, you can get the same number of ports depending on which vendor you're buying it from. Ranges probably between $10,000 and $20,000 street price. If you're a large user, you'll probably get a better discount. But just for comparison purposes, there's quite a range. All of the switches today run, I would say, proprietary operating system. So Juniper has Junos, and Cisco has iOS or Nexus OS, and Arista and Force 10. Everyone has their own, including the upper right, the Lenovo. We have our own operating system. And it's all really a base. And then on top of that, you run different networking protocols. And those are typically standard-based protocols, although some of the vendors have some proprietary things. Most vendors interoperate and have standard-based protocols that they run. And here's where it gets a little trickier. So now I've got the same hardware basically running a unique operating system. So now when I go to configure the switch, I've got a different command line. Each of these are a different vendor. They're a little bit different. It's hard to show differences in these small snapshots, but the idea is, someone that has to add a VLAN to ports on a switch that's a Juniper switch, we use different commands than they would use a Cisco. And a lot of the other vendors use a Cisco-like command line, and that's true with Lenovo too. In the Cisco world, to configure a VLAN, it's called switch port mode trunk, and then you have switch port mode allowed VLAN, and you list the VLAN numbers. And that's the same syntax that we use in the Lenovo world. And that simplified things somewhat. But basically, in a networking world, if you have 2 switches or 4 or a whole mesh of switches, in a data center, anytime you add a new VLAN or a new type of connectivity, you basically have to go to each switch, log in, make the change, and then you'll have connectivity through, from the data center, from the servers out to the core network, where either you have internet connectivity or where your users sit. So talk a little bit about what the hardware is like. Focus on Broadcom chipset and switches and command lines, and now that really creates some issues. And you see that a lot of the things that so like server network virtualization or server virtualization, they have Intel. Network virtualization, we have Broadcom, but really in the software level and operating system level, these are still proprietary, and the way that you configure devices are still manually and usually one at a time. So what does that create? It creates issues of inefficient network bandwidth utilization. I might have multiple paths throughout my data center, and some of them might be heavily used and some might not be used at all. And that's really important in a wide area network, right? If I've got the link from Detroit to Chicago and it's low, the utilization isn't great, it's hard for me to add more utilization because that means I usually have to have more fiber put into the ground and new routers configured at either end. And it's very difficult. It's a little easier in the data center, but still have, you want to make sure that I'm using all the bandwidth that I have. By the next comment, I mean the physical path network functions. I've got some drawings that show you that, but basically if you're in a data center and you've got an application that you want to have access to the application managed by a firewall, the path is usually from the server to a top rack switch to a distribution switch to some kind of a core switch, and then over to the firewall and then back. And then every packet that has to go through the firewall makes that same path. So I've got physical paths that, because of the way that the networks are built today, makes the path inefficient. Again, like I said earlier, network devices are typically provisioned manually, and we're really focusing on switches today, but other network devices I would consider are load balancers and firewalls. And typically, if you're buying best of breed, you might have a switch from one vendor, and you might have a firewall from another vendor, and then your load balancer be from a third vendor. And of course, those tools and the configurations aren't anything alike, right? You might even have to, in a large network, you probably have experts that there's a firewall person or a firewall group and a switch group and a load balancer group. And so they all have different expertise, which is expensive to have to support that kind of environment. And then what really the end all be all is, I work with a lot of folks, and they're going to implement new Lenovo servers, and you can load operating system, upgrade the firmware, and that happens pretty quick, and then they're ready to start network connectivity. And usually it can take, if it's a small environment where a small group of people have total control, it might take a day or two to have all these switches and firewalls configured for the connectivity. If it's a larger organization, it might require change control that might only happen on a weekly basis or maybe on a monthly basis. If during that change control there was a mistake made in the configuration of the device, now you're off to the next change control window. So it's very complicated, and there's reasons why, right? Because someone's got to touch a switch and a router and a firewall and a load balancer all the way along the path. So there's lots of room for error, and there's usually time built that it takes to implement new compute and new storage technology. It takes much longer to do networking. I'm going to take a breath, and now I have this titled Software-Defined Data Center, but I've only got a couple slides on that. But we're really going to talk more about network virtualization and software-defined networking. Because what we're trying to do is, again, on the compute side, we've pretty much solved with management tools, and if you're a Microsoft shop or a VMware shop, those operating system vendors have made tools so that you can coordinate efforts and make things much smoother to implement new compute or migrate from one set of compute to another, or the same thing with storage. There are storage tools that do that already. But we're lagging on the networking side. And, and to be honest, as part of it is network switch vendors will lag because there's still some value in their operating system and the training that users have that are experts in these tools that, really it's not to their benefit to move to something that's software controlled or automatically controlled or through some orchestration platform controlled that way. So, but, the the benefit of this whole software-defined data center is to, get applications that run the business up and active and have the highest amount of the best performance, and what's good for the business, right? IT architecture is one thing, but at the end of the day, it's got to run business applications that either make users, the company employees more efficient, or allow you to do better commerce with your customers, right? So that's IT for IT. It doesn't really isn't as important as it is. It either generates revenue or it causes employees to be able to fulfill their job. So you've probably seen this before. I found this from an IBM presentation, but it's just a generic software-defined data center. And really, what we're looking at, I'm trying to bring out my little pointer here. It's this middle level right here, right? So this is the idea of an application that can control compute and an application for storage and networking, and that those application level things talk to the physical devices that make up the network and the storage and the compute. And above that is really monitoring and orchestration. And what I mean by orchestration is coordinated applications that say, oh, we're adding a new VM and it needs X amount of resources, and then since someone's doing that and it comes up that they need 10 terabytes of data, then that orchestration layer will go tell the storage system to add a volume with 10 terabytes of storage for the application, and then maybe configure two networking ports on a switch that's connected to that compute resource, and configure that for their 10 gig ports, but maybe we're only going to give that application 5 gigabits. So again, something that controls all that really well without having to touch each piece of equipment. And that's really the end all of the software-defined data center, is not only allowing users to bring up applications easier, but then have, at the top level, have the applications tell this orchestration platform to, hey, I need more resources. I'm running out of capacity. I've got more users that are trying to access me than was originally planned, and that application would have hooks that would talk to the orchestration layer, and the orchestration layer might fire up either another VM or increase the resources on that virtual machine for that application. So high-level stuff. That's not really the point of the presentation today, but just to give you an idea of how, when we talk about network virtualization, how that helps and fits into this architecture. So this is just kind of another view of the same idea. It happens to be from OpenStack, but really it could be any cloud operating system. The next slide we'll talk about is kind of a VMware-specific slide, but again, the pools of resources, again, are storage, compute, and network, and that's what we're trying to kind of control in a friendly way so that users and administrators can manage those devices from an application point of view without having to know the command line of a switch or to know the user interface of a Lenovo S3200 storage array. This is about the simplest slide I could find that kind of details that idea. Again, so this is another OpenStack slide, and this just really is to show that these are all vendors that provide some type of OpenStack application platform. So a Red Hat, IBM, VMware, even VMware. I was even surprised to find that you can buy OpenStack from VMware. And of course, it's open source, so you can build your own OpenStack just by, running Red Hat or some other Linux distribution and adding all the parts. But these are all and there's probably 2 or 3 times more vendors. I just try to pick the more popular ones that create and that have an OpenStack distribution. So along with that, another way to provide this software-defined data center, and VMware has their own suite, really, of products called this vCloud. This is a little old, so some of the names have changed. I know they kind of moved things in that are not vSphere, but some of the higher level operations are called under their vRealize family now, so that it's not identical to what's there today, but it'll give you an idea that you can pretty much buy a whole suite of products from VMware that can do the automation at the higher levels and then operations, so that it has software hooks and APIs that talk to either their own products, right, the Site Recovery Manager or their virtual SAN products, or of course it'll work very well with vSphere for the hypervisor. And then they have their own networking applications that they run at the host level, not necessarily on a switch, but they move networking functionality into the host, into the hypervisor, so that now they can automate things like that without having to have hooks into the network switches. And we're going to talk a little bit more in detail about that. And the same thing with OpenStack, where in VMware their networking hook into their automation platform is called NSX. In OpenStack, it's called Neutron, and Neutron is the networking piece, or the networking functionality that's provided in OpenStack. So we talked about on a high level, software-defined networking, software-defined data centers, and now we're going to focus a little more on this software-defined networking. So this is kind of a slide that I thought was interesting, and 87% of businesses plan to have SDN by 2016, and really there's two types of SDN, and the names kind of used intermittently and depending on which product you're talking about, but there are really two different types of SDN. There's an overlay type of SDN, software-defined networking, and that's where you run some type of networking functionality in your hypervisor or on a server. And then there's a second type of SDN, which is related to a protocol called OpenFlow. And OpenFlow is a switch protocol, right? So I have to run OpenFlow on my physical hardware switch, and they both provide functionality that allow a controller device to direct traffic or policies or load balance applications from some type of controller. So it's another host making decisions. Currently in networking, if a server's trying to talk to storage, the server has knows the destination address of the storage. We'll assume it's an IP storage connectivity. Each switch along the path, each router along the path, makes a decision which port I'm going to forward to get from the source, which would be the server, to the destination, which is the storage. And in SDN world, whether it's an overlay network like NSX or if it's an OpenFlow type network, they both have an outside controller that kind of directs the path from the server to the storage, independent of the physical path. And I've got some good slides that will show you that. It's a little bit difficult to discuss up front, but hopefully the pictures will make more sense. And again, the idea of this SDN, or network virtualization is another word for it. It matches up with things that I talked about earlier on, some of the limitations of the current networking implementation. So here's a good example. I borrowed this from VMware. There are two different, let's see here, I'll get back to my. So this is kind of a traditional, there are two different examples here. I'll look at the left first. I've got a virtual machine inside a server, and then it connects to a layer 2 switch, and then up at the top it goes to some kind of a core device. If my two VMs are in different subnets, which is fairly logical, usually if you've got something like a database might be in one subnet, and a web server farm might be in another another subnet, the physical path has to go up to the layer 2 switch and then back down to the core. So now you'll see there's latency involved with that, and as well as this is why every device in the network has to be configured when you add new subnets or new VLANs into a network. Now if we go over to a network virtualization view of that network, so now I'm going to put this layer 3 routing for VLAN to VLAN communication. Inside the hypervisor, I can go from one VM to another VM without having to go to any other networking device. So, obviously your eyes tell you that that's a much simpler path, and so not only is it simpler, it makes sense, right? I've got some. Why do I need to go a physical path like that to accommodate something that is one VM talking to another VM on the same host? Right? It just kind of makes sense. So the next example over here shows actually VMs on 2 different servers. Same thing idea. I've got to go up to some kind of a router type device and then back down to the second VM. And when in this, the arrows are like this, it's not just the first packet or the first communication. Every packet, every communication between the 2 VMs has to take this physical path in and out of the chassis, out of the server into some kind of a layer 2 switch. And there might even be another layer of layer 2 switch, just depending on the size and the scale of your network, and then back down to the other VM. Again, with this network virtualization, I still have to go to a layer 2 switch because I'm in a physically separate server. But maybe that layer 2 switch, if I'm using a blade chassis, like a flex chassis, that layer 2 switch resides right inside the chassis. So I still have, my 2 applications are in different subnets. I haven't broken any rules, but now I'm able to go just with a single switch hop from one server to another server. And then again, in a blade center or a flex chassis, that communication wouldn't leave the chassis at all. So you can see it kind of makes some sense, right? And this really traditionally, that's how networking is done. Is you have some kind of a layer 3 device that's connected to a layer 2 device, and then you have all your compute connected to that. So the last slide I used showed VMware NSX, but again, we don't promote any of the vendors, but I just wanted to give you an idea of vendors that provide this level of network virtualization. And it's basically software that works in a server that provides networking services. Some of them, so VMware would provide you the whole stack of automation and orchestration, but you can also use the VMware NSX in an OpenStack environment. So maybe you're using OpenStack as your orchestration tool, but you could still have OpenStack talk to the NSX controller and then have it manage the network forwarding of traffic. Might occur as another one, Plum Grid, and then VUG network. So there's 2 different types of SDN and/or network virtualization, and what people usually think of when you hear SDN, or software-defined networking, is OpenFlow. So OpenFlow is really just a network protocol, and by itself it doesn't have anything that has an orchestration platform or automation, anything like that. But OpenFlow has, by design, is made to connect into an OpenStack infrastructure. So if you decide OpenStack is the way to go, that's what you're going to, base your cloud management platform on. Then OpenFlow is another way to do it. And the companies on the left side, Project Floodlight, is really an open source version of OpenFlow. And then Open Daylight is a consortium of IBM and Cisco and VMware. A bunch of networking vendors actually got together and kind of came out with this. I believe it was in 2013, Open Daylight started shipping. NEC is another company that makes a very popular OpenFlow controller. But again, so now with this, it's not, I can't use my normal or my typical layer 2 or layer 3 switch. I have to have a switch that supports OpenFlow. So it's a little more complicated. It's more of a replacing my network infrastructure with something that can support OpenFlow. Let's see. So my example earlier showed what network virtualization, how it can be more efficient to do that. It's just routing functionality, right? So I'm going from one subnet to another subnet. But really, there's something in addition to network virtualization called NFV, or network function virtualization. And that's kind of going one step further. So today, over on the left-hand side, you usually have some kind of an appliance that's a firewall, and it's probably a pair of them, so you have some high availability. And you might have an appliance for load balancing. So that load balancer allows you to, usually they're internet-based, and they have, as I type IBM.com or Lenovo.com, that request gets a load balancer in Lenovo's data center, and then gets balanced across any number of servers that can reply to that request. Another appliance device would be something like intrusion detection. It's something that not only is looking as a firewall, but it's actually looking at the data inside the packet to make sure you're not sending any viruses that are included in an HTTP packet, for example. So all those things today are separate appliances. Those vendors typically sell, one new box that does that, and they sell them in pairs. And again, they're all managed separately, and you usually have to have expertise inside the company to run and manage those. The idea of network function virtualization is to not only put routing functionality inside the server or inside the hypervisor itself, but to put some of these other functions like firewall and load balancer and intrusion detection inside the server at the server level. So let's take a look at that. That looks like, so if we look at our drawing again, in a traditional way is typically outside of the network where there are public addresses, right? So somewhere usually connected to a router that has your internet connectivity. You'll have firewalls or pairs of firewalls, and then you usually have applications that sit in a DMZ or demilitarized zone that basically has public addresses, and then either through a firewall or some other device, those public addresses get converted to an address that you use inside your company that are private addresses. So what could be a firewall, it could be a load balancer, or it could be VPNs, another example of this functionality. Every packet would have to go through the network out to the firewall and then back through the network into the data center. With this idea of a network function virtualization, I can apply that same functionality at the host level. And again, I'm showing NSX, but it's because I had a nice and easy to use picture. But any of those other products as well can provide that same functionality, Mitochora and PlumGrid, and I'm sure there are open source examples of that as well. But I was just trying to give you an idea of some of the commercial products that are out there. So overall, what you should, hopefully you're kind of getting the idea that, these hardware devices that I buy for networking, including firewalls and switches and routers, are really, if you buy off on the idea of a network virtualization, that they're becoming less and less, I'll say important, but because switches today are really based on Broadcom chips, and they're becoming more commoditized, that the feature set that you need in a switch and or a router is going to be more limited, because a lot of that functionality is going to be moved out into the servers themselves through some kind of a software package that you won't need to have a 10,000 feature router any longer that you're paying quite a premium for. You might get away with a 1,000 feature router that works really well with the network functional software that we're talking about. So that's where we're kind of going to lead into the Lenovo networking products and how Lenovo is designing and implementing products that do networking that really fit well into the network virtualization world. So I talked about the three values earlier: simplicity, the three keys: simplicity, open, and then really cloud ready. And at a higher level, here's really the value that we see with and we try to impress customers with that we can provide in our switches. Our switches are all Broadcom-based switches using the latest chipset, and I'll talk about that when we talk about the specific products. But the idea is that they're usually a much better cost, capital cost, and they have lower costs to not only in the maintenance cost, so as far as like a maintenance contract, but also in power and cooling as well than the other switches. They're easy to manage, and I've got some examples of some ways we do that. We'll talk about interoperability, and then really how we support open systems, right? So we're only selling switches into a data center, and that really puts us in an advantage because we're ready and available to support the OpenStack, the VMware, vCloud, and SDN because we don't really have any vested interest. We don't make firewalls. So to put a firewall in a hypervisor, that makes a lot of sense to us. And what we really want to provide is a very good cost-efficient switch that has high performance. The high performance is low latency, and it's also the port density that I mentioned there. But it's just a solid performance switch that's got lots of experience out in the market, and with the support group through Lenovo and through IBM, to support you if there are any either software issues or if you have any hardware issues. It's the same support channel that you have as if you had Lenovo servers. So let's look at this real quick. So this is kind of a little more expanded version here. My servers actually have applications and hypervisors on them. And again, this is really what we're seeing that customers, and it's not going to happen overnight, but we think this is really going to move forward. And that's why we're writing software into our switches that have the connections to not only OpenStack and OpenFlow, but the other platforms as well, VMware and Microsoft as well. So you can see the Lenovo boxes are our switches, so top of rack switch environment, and then possibly the next level up would be some kind of a distribution layer. Oh, sorry about that. A distribution layer switch, and then connect to a core. And you can connect to a core, whether it's a Cisco or a Juniper or some other vendor, that because of the interoperability that we show every day, that we connect our switches to those environments. Usually when I spend a lot of time helping business partners and customers and IBM integrate the Lenovo switches into the environment, and usually they kind of don't really believe how easy it is to do. So it's kind of I spend more time explaining why it's simple and less time really doing the actual connectivity. But anyway. So again, this is just another view of the software-defined data center, but now instead of OpenStack environment, we're looking at VMware view of things. So again, it's NSX. These are some features that we've already implemented. This NSX gateway. So an NSX gateway is a feature that's required in a hardware switch in the network that allows a VMware NSX environment to communicate outside to a non-NSX. So if I've got servers, maybe I don't want to implement network virtualization on maybe my older servers, but I want to do it on my newer servers. That provides a gateway that maps VLANs and subnets back and forth between the two environments. So we have that today running on our switches. And then some of the management tools as well. Today we have a plugin for VMware's vRealize. If you use the vRealize tool, it's basically the Log Insights tool. Log Insights is part of the vRealize family. And it provides a syslog messaging. And what the benefit of VRealize is that different vendors, so you could have your Windows servers have a plugin, and of course the VMware vSphere hosts have a plugin, and the Lenovo switches have a plugin. So, for example, if a switch port went down, you might lose connectivity to a vSphere host, and then maybe you might lose the Windows server connectivity. With VRealize, it puts those three things that happen, and normally you'd have to go through the syslog of the switches and the syslog of the VMware and syslog for Windows. But with VRealize, it kind of coordinates all that information and says, oh, well, what happened first? And so the first thing that we noticed was that, oh, a switch port went down. And then that kind of gives you the idea of, I had a trail of failures, but now I can look at them all in one place and kind of coordinate all that. The second piece with the automation and the operations, those are still in the future. Actually, the operations piece is coming shortly, but the automation is a little bit further out. But these are all features that allow our switches to really work in a VMware NSX network virtualization environment. I've kind of listed a couple other things at the bottom there, the OpenStack. So where ML2 is the name of the feature that I don't remember what it stands for, but it's a hook from OpenStack into switch manufacturers, so that OpenStack doesn't have to know the command to add a VLAN to a Lenovo switch. It just knows that it knows how to do that to an ML2 interface, and then we'll have the ML2 interface on our switch. Again, that's a future thing. We don't have that today. So that's really the cloud pieces. Those are the two ideas, that our switches are very solid performers and that they will migrate right nicely into a cloud infrastructure. The next thing I'll talk about is simplicity. So we have the idea. One of the tricky things, and one of the things I hear is about implementing Lenovo switches into an existing environment. Maybe they have HP switches or they have Cisco switches. And that even though the commands are similar, we have a mode called Easy Connect. And what Easy Connect does is it transparently passes all the traffic from a host to either the core network or some other distribution switch inside the network. And what do I mean by that? I mean, typically, if I've got 10 VLANs that my servers are using, or 10 virtual networks, or 10 subnets, if you want to think of it that way, every switch port that touches every server, and then every switch port that connects to an upstream switch or a router, you'd have to add those VLANs on the configuration of each switch port. So it's not difficult, but it's tedious. And if you miss one, you might have think you might have some redundant connectivity, but if you don't have all of the VLANs on every port, you might end up with a port that goes down and maybe one subnet's not reachable anymore. And there really aren't any tools that go out and check all these VLANs on every switch and every host and every NIC. It's kind of done manually, so it's not an easy thing to coordinate. So the idea behind Easy Connect is it simplifies the command. So I try to show you on the left side is a standard switch. It happens to be a Lenovo switch, but so basically the switch port numbered are let me see. Come on. Here I've got switch ports 1 to 64, and I'm going to put all of these VLANs on all of the switch ports. And sometimes people don't put every VLAN. Maybe you've got a server that only needs to have connectivity to 1 or 2 specific VLANs. So then you only configure those ports for those VLANs. Most network people, they configure every switch port for every VLAN because it's easier to administer that way. In the Easy Connect mode, I've got kind of transparently will pass any VLAN that I see from the host up to the next switch. And it's really as simple as this. If someone's interested, I'll talk to the customer, and if that's something that they're interested in, I can send that in an email. I can do that in a WebEx, but basically it's these 2, 4, I've got about 10 commands there. And if the customer's got 100 VLANs or 2 VLANs, the same same configuration will work on a switch that's an easy connect mode. It still provides local switching, so if I've got two servers and they're connected to the same switch, the traffic flow would go from, it would stay within the same switch. It doesn't require traffic to go up. Some other vendors have either easy mode or switches that aren't really switches that forward traffic up to the next level of switch. And that allows you to not configure the first level of the switch, but then I've got to configure those ports somewhere else on another switch in the network. This is about as technical as I get right here on this in this presentation. So another simplicity. I had a slide that I took it out just because it doesn't really show much, but I can tell you that storage, everyone knows storage is growing and the need for storage is growing, exponentially or very large percentages every year. And still, I would say a majority of the customers that I work with still have separate Ethernet and fiber channel networks. But we do have switches that support a converged network and really converge two ways. One could be that they're going to use iSCSI for their storage protocol instead of using fiber channel, and that works really well, especially in a 10 gig environment. You have lots of bandwidth, and you can, by using VLANing correctly, you can separate the iSCSI traffic from the rest of the network traffic. But specifically with FCLE, right? So if you're looking at fiber channel over Ethernet, some of the other vendors in their data center products, they only support FCLE, they don't support fiber channel. So they kind of push you to go along that way. But we allow the option of both, either they're maintaining your existing fiber channel environment if you have it, or moving to something that's FCLE based. And in an FCLE infrastructure, there are two different functionalities that are required of switches. One is this start with a simple one, FCLE transit. So basically that switch recognizes FCLE packets and it prioritizes them so that they have the bandwidth that they need. It also communicates that it knows that there's a device connecting to it that can understand FCLE. So it provides, so like for example, flow control. So in a standard Ethernet switch, if a server's sending it too much traffic, or not, maybe they've got 10 servers connected to a switch, and they're all sending packets to an 11th server on the same switch. We'll pick a simple example. If that 11th switch port is becoming congested because I've got 10 coming in and 10 going out, the solution to that is tell all 10 servers to stop sending traffic. In an FCLE world, that now you break your connectivity to storage, which is really bad. So in an FCLE world, the flow control is more advanced. It's called priority flow control. So I can tell those ports that are connected to the 10 servers to stop sending the non-FCLE traffic, and then that way it can differentiate between FCLE and non-FCLE traffic, so that your storage traffic still has a priority and still can flow without having to stop all the types of traffic that are coming in on that switch port. And so anyway, so that's what an FCLE transit switch does. So this type of switch, an FCLE transit switch, would still be Ethernet packets coming from the host and then Ethernet packets leaving the switch. The next type of FCLE switch is called an FCF target switch, or an FCF fiber channel forwarder. And that takes Ethernet packets coming in from a host, and that switch has fiber channel ports on it, so that I can connect either another fiber channel switch, or I can connect to fiber channel storage directly. And then again, that does things like zoning and provides the set of fiber channel services that a traditional fiber channel switch that would perform that as well. Again, we have switches that operate in both modes. we'll talk about that when we go through the specific product. So interoperability. We've spent money to having the Tally group continually, they're a little old, 2012, but there really haven't been too many new protocols in networking since 2012. So they made a great recommendation that we are compatible with Cisco Nexus and Catalyst switches, and can provide that link to you if you're interested. But I can tell you every day, I work with customers and work with business partners that provide, connectivity into their network from a Lenovo switch. And I've worked with Juniper switches and Cisco switches, Brocade switches. Let me see, HP switches. I did that a couple weeks ago. Really, the beauty of Ethernet is that it's interoperable. If the other vendor is doing something proprietary, then it may not be supported. But almost everything you do today is interoperable because that's the way Ethernet was defined. Oops, sorry about that. I missed one. So, this is really some milestones. It's kind of, again, because we were kind of hidden under the IBM name and under Blade Networks providing switches for both IBM and HP, we were really the first 10 gig switch maker, right? We were an innovator and a leader in that area. Same thing with fiber channel over Ethernet, and again, high speed bandwidth switches, and low cost per port, really, and that's what is another benefit, even now more so that we're with Lenovo, that even the switches we sold previously are a much better price point. And again, like most of the switches that are in that list there that we're looking at the bottom of the screen are Broadcom-based switches. So you're typically buying the same type of hardware with just a different logo on it. I'm going to take a quick drink. And we'll talk about the switches. So I tried to minimize I've probably got 10 slides, but we won't spend more than a sentence on each slide to give you an idea of the switches. There are two different families of switches. The one's the 7000. It's layer 2 switch only, so there's no VLAN to VLAN communications. It's just a layer 2 switch. Typically, these are used as management switches. If you've got an IMM port or a management port on maybe a 10 gig switch, you would connect to this type of switch. So usually it's not traffic, but it could be still a layer speed if you've got 48 1 gig ports and you want to forward traffic at full rate. These switches will definitely do that. They do not have redundant power. But if you need redundant power, we have another switch that I'll talk about on the next family. Or there's a power shelf that looks like a switch, but it has just DC connections into it so that you can connect and provide redundant power. So there's the 7028 model has 24 1 gig and 4 10 gig. The 52 model has 48 1 gig and 4 10 gig. The 8000 family is really the premier family in the Lenovo line, and with the exception of 2 of the switches, they all support OpenFlow. All of the switches that you see can support an environment like NSX or like the implementation of network virtualization through Midokura or PlumGrid. Those software-based network functionality implementations will work with any of the switches that you see. But for the most part, they're just different numbers of ports. And you'll see as we go through the switches real quick here. The first switch is a 1 gig switch primarily with 4 10 gig ports, but it does provide OpenFlow, and it does supply a rich feature set of layer 3 features as well. It can do BGP and OSPF. And again, all of these switches have the Cisco-like command line. All of the switches that we'll talk about in that 8000 family all have redundant power supplies, and they're built in to the switch, so you can't buy a G8052 with only one power supply. We know these are data center switches, and it's that important that you have redundant power in them. All of the switches come with a 3-year warranty for hardware and software. Some of the other vendors sell switches that have lifetime software, maybe even lifetime warranty, but usually they're limited, or that sometimes they don't include a fan or a power supply. But on the higher end switches that the vendors sell, you'll see that they usually do not have a lifetime warranty and lifetime software support. So it's something you have to consider when we're looking at a really good price from Lenovo, but then we also supply the second power supply, and we also supply the warranty as well. All of these switches have, used to be an Ethernet switch, if you had a 10 microsecond latency, that was a good, everybody had 10. But really, with the new Broadcom chips that are out, you should always be under 1 microsecond. So for example, if you see over here, 570 nanoseconds, all the switches that we'll talk about, some have that number, but they're all under 1 nanosecond. I'm sorry, 1 microsecond. So for example, so this is 0.57 microseconds is equal to a nanosecond. So to just kind of give you an idea. So this is a new switch, and so we had a 48-port 10 gig switch with four 40 gig ports. This switch actually comes in at a better price point, and it gives you 2 more 40 gig ports. So I can use 48 10 gig, and they could be a 10 or a 1, depending on what kind of object that you put into it. And then you have 40 gig ports. Those 40 gig ports can be used for 40 gig, or they can use a different type of connector. And there's a breakout cable that allows you to use those 40 gig ports as additional 10 gig ports. This being one of the newer features, this would be the Broadcom 2 chipset that has a VXLAN feature. That's really an important feature for network virtualization, both in OpenStack world and in a VMware NSX world. And the interesting thing is this switch is actually less cost, a better price than the 8264, which is 1 generation older. But again, because of the new chipset that we get from Broadcom, that allows us to provide more ports, lower latency, and actually a better price point. So this is if you have in a Flex chassis, there is a 64-port 10 gig switch that is the peer of this G8264 switch that provides all the same functionality. Yes, now this is our converged switch. So the difference between this and the previous 8264, the last 12 ports on the last 12 ports right here can be either 10 gig Ethernet or fiber channel, 8 gig fiber channel. So again, this could be a switch that would perform the FCF functionality. And of course, it has a peer switch in the Flex chassis called the CN4093, same number of ports and functionality. And this is along with the 8272, this is a new switch that we just announced, and it's shipping as well, to provide even more 10 gig ports. So this has 86 10 gig ports and up to 10 40 gig ports. You'll notice it's taller, right? It's a 2U switch, but that's basically because to get the number of interfaces on, you couldn't fit that many interfaces on the same in the same 1U frame. This switch also has just a single Broadcom chip in it, and it's a wire speed switch. It supports that maximum number of ports that switch does, even though it looks like it might have multiple forwarding chips inside. This is really just one chip, and it's just a taller frame so that it can fit all the physical port connectivity. And again, this one supports VXLAN as well. Okay, so appreciate your time here. We're almost to the end. Hopefully we'll have some questions, but I've got customer references, but it's more of different use cases. This one slide sums up most of it, but I do have a couple more slides at the end just to break them out a little bit more. But if we look at the upper left, it's the access layer connectivity. So this is typical top-of-rack switches. Usually customers will have two switches per rack, or maybe 2 switches per pair of racks, because we can support 48 10 gig ports, and then 4 40 gig switches. I'm sorry, 4 of the 40 gig ports. So any of the switches that we talked about, depending on how many compute nodes you're trying to connect to, and then what kind of uplink bandwidth that you want. So usually, typically they're in pairs, so they have redundant connections. Dropping, over to the upper right is it's really the old kind of thought process of designing data center networks was a 3-tier network where you had some kind of a chassis device that was the core, and then an access, a distribution layer and an access layer. And really, the more and more data centers to get high speed, it really going to more of the leaf and spine environment. And you'll see this is really a 1 gig to the host, and then 10 gig providing the backbone connectivity. And then if we drop down one to the lower right, now I've got 40 gig connectivity between the switches, and then 10 gig connectivity to the host. And you'll see that I had a slide in here, but I left it out. But it talks about really in the last 3 to 5 years, the number of fixed size switches is growing much more rapidly than the chassis switches. That this type of design where you have kind of 2 layers of switch is much more cost effective and actually high performance, because you can say, okay, between my rack switch and my spine, my leaf switch and my spine switch, I can put one 10 gig pipe between there, or I can put a 40 gig pipe, so I can control the bandwidth. If you buy large chassis with multiple switch modules in them, usually the backplane bandwidth between the 2 switches is fixed. And the only way to do that is either get a new chassis, or some vendors allow you to buy a new fabric module, and that might improve the performance. But sometimes if you buy the new fabric module, then you need to buy the new the leaf modules as well, so that they have the improved performance also. So you keep your chassis, but you basically replace everything inside. So customers are finding that using these high performance 1U switches provides a much better price and a performance as well. Usually if you get a better price, you need performance, but in this case you get the bonus of both things. And you have more physical devices to manage, but you still have the idea that you have high performance and a better cost. And then kind of coming all the way around to the lower left side, we have an implementation using our 8264 CS switches that allows us to connect up to 9 of our flex chassis. And it's in a similar mode to what I described earlier with the Easy Connect, that all of the switches that are inside the flex chassis require no configuration at all. They come from the factory in that Easy Connect configuration. So they will forward all of their traffic up to the 8264s, and then the node switches will connect to the customer core network. So the only time they have to configure anything is right here. And even though there's a pair of these switches, there's a master and a slave, so that I really only have to configure one switch to support up to 9 chassis of compute nodes. Here's a couple other drawings ahead. What I wanted to show in this one is really this feature that we call VLAG, and it's similar if you're familiar with Cisco switches. They call it VPC. Juniper calls it MC lag, but it's the idea that these 2 physical switches look like one logical switch. So the host down here has maybe has a 2-port NIC, and you can configure it for NIC teaming, but I don't have to configure it as active backup anymore. I can configure them both as active, and it logically looks like one 20 gig pipe connected to one switch at this level. So it's a nice feature. And not a number of vendors have it. Unfortunately, it's not a standard, but the protocol really only goes between the two switches. So if I had another vendor at this layer, they could run their protocol like VPC, or as Juniper calls it, MLAG, I believe. You could run MLAG or VPC at this level, and then you can run VLAG here, and it's very interoperable. And the NIC in this host knows nothing about it. It just thinks it's talking to the same physical switch. And kind of going back to the, we have Lenovo switches in some very large data centers and some very large clusters. This would be an example of a very, I guess, a high-end configuration where, that down here I've got flex system chassis. These could be, though, just racks of typical rack servers with standalone switches, the top of rack switches in a rack, and then connecting with X number of uplinks here to this middle level. And the middle level, in this case, we're doing FGOE, so we're providing fiber channel connections up to the SAN switches, and you still maintain an A side and a B side. How you configure this is that you don't have any of the FGOE traffic using this link between the two switches. All the FGOE traffic stays the A side, and then you have a B side, just like you do in fiber channel. And these could be a Brocade switch, or they could be a Cisco SAN switch. It makes no difference. In this case, the customer at the next level up is using Cisco switches, but again, we're using the VLAG feature at this level, and then they're using VPC here, and then they can use it up here as well. So again, just to show you the interoperability, this is really taken from a customer's network documentation. One of the things too, I'm one of the field guys in Lenovo, but I'm going to skip that one. But there are a number of us out in the field, and of course there are numerous headquarters resources as well. But we're out on the street working with business partners and customers every day. If you need to get in touch with someone, you can gladly give me a call or send me an email, and I can reach out to sign you up with the resource that can be the most helpful. And that's really it. I know I kind of talked a lot about things other than the Lenovo products, but the idea I was trying to impress was that paying a lot for Ethernet switches today really isn't a requirement. And if you're really comfortable at looking at some of the new technologies in network virtualization, you'll find that what you need is just a high performance, high quality switch that's at a really competitive cost. Will work really well in your environment. And at the end of the presentation, too, there's some links in the PDF file that you can get more information.
Thanks, Tom.
Slide.
Yeah, this is exactly what we were looking for. Very detailed, very thorough. It's exactly what the x86 technical, if you will, virtual user group is about. So I appreciate it. It was so thorough that I'm not seeing any questions out there. But we'll give it a minute here to see if any questions come through at the last minute here.
Great.
Yeah, hi Mark. The slides will be available for download. I understand there's a permissions issue for people outside of Lenovo with the link currently, so I'll be posting it somewhere externally to download. So look at that link, the short Google URL link that is on there, and I'll also be sending out an email when I get that fixed. So look for that email. All right, looks like we've had quite a few users dropping. I'm not seeing any more questions coming in. So with that, Tom, we'll go ahead and conclude the call. Again, thank you for your time, and thanks everybody for participating and attending. We look forward to future releases and information around networking.
Thanks, Ben.
Thanks, Tom.